guys, Dr. Rob Barrington here with some more nutrition advice. I wanted to do a quick video today on dietary fat, but I didn't want to do a video that explains anything in particular to do with the nutrition of dietary fat. I've done videos about fat before, I've written many articles on my blog about fat. What I wanted to do is use some examples to illustrate the way that dietary fat, when it's discussed, really needs qualifying statements regarding what aspect of dietary fat in particular you're talking about. Dietary fat is often grouped together. All dietary fats are often grouped together. They're given this terminology as fat, but really that's a misnomer. It doesn't take into account the nuances of this large group of heterogeneous chemicals that actually have very different effects in the body. So when somebody, for example, says, you know, low fat diets cause X, or weight loss is helped by a low fat diet, those statements really don't mean anything, because fat is not a single compound. It's like I say, a large heterogeneous group of chemicals, and those chemicals within that classification of dietary fat can have, you know, diametrically opposed effects in the body, and therefore it's worthwhile just I thought it would be worthwhile just doing a quick video just to explain why that is the case. If we take dietary fat, we really should be talking about dietary lipids. Lipids are non-polar, they're hydrophobic, they're a large group of chemicals, and some of those chemicals are important dietary components. Now, when we talk about fat, what we're really talking about is fatty acids. That would be the chemical name of what we're talking about, and that is just one subgroup of all of the dietary lipids. Other dietary lipids include cholesterol. We've got some of the vitamins are dietary lipids. We've obviously got fatty acids, triglycerides as well. There are phospholipids that are important dietary components. And so you see, this is a large group of chemicals, and all of those subgroups within what we call dietary lipids can have very different effects, and they're needed in humans for different reasons. The main group of fats would be, main group of what we call dietary lipids would be triglycerides, and they're just three fatty acids joined to a glycerol backbone. Now, even the triglycerides can be very varied, because the fatty acids that are joined to the glycerol can vary not only in their chain length, they can also vary in their degree of saturation. A fatty acid, the dietary fatty acids that are important to humans vary in chain lengths from about four carbons anywhere up to maybe about 26. There are some that are more common in the diet than others, but those are the chain lengths that we're really interested in from a dietary perspective in humans. Now, that chain length affects the way that the fatty acid interacts with our physiology. The short and the medium chain fatty acids, for example, are not absorbed in the same way as the long chain fatty acids. The long chain fatty acids are absorbed into chylomicrons, they pass into the lymphatic system, and then they pass through the subclavian vein into our blood. The short and medium chain fatty acids don't go via that route. They go straight to the liver. They're much more likely to be oxidized by the liver as a source of energy, and this is why medium chain triglycerides are often used as a dietary supplement for athletes to provide an instant form of energy, more similar to carbohydrates really than normal longer chain fatty acids. And that's because once they're in the liver, they're much more likely to be oxidized, and therefore they're used as a source of energy. So even if we look at the basic classification of the chain length, we see that there is a difference there just on the absorption and the initial fate of those fatty acids. So that's a nice illustrative example of how the chain length can affect the physiology. If we look at fatty acids, they can also be classified as saturated or unsaturated, and again, the classification of those of the level of saturation is also determines where these fatty acids end up and what they end up doing. Saturated fats, for example, there is some evidence that they're much more likely to be stored as a source of energy compared with polyunsaturated fatty acids. Certainly some of the fish oils, which are polyunsaturated fatty acids, I would say have a much lower propensity to be stored as in adipose tissue because they have vital functions, for example in cells. So they're much more likely to be used for their essential functions than they are to be stored. So we have saturated fats, which have their chain lengths saturated with hydrogen. Their carbon atoms are saturated with hydrogen. We have monounsaturated fatty acids, which have a single double bond, and then we have polyunsaturated fatty acids, which have multiple double bonds. And those double bonds cause the molecules to be kinked, and that kink in the molecule can then be used by cells in order to be able to increase the fluidity of their membranes, for example. So if you incorporate more saturated fats into the phospholipids in membranes, that will increase the rigidity of the cell membrane. If you include more polyunsaturated fatty acids, that will increase the fluidity of the membrane. So the cells can regulate their membrane fluidity by using different fatty acids. So dietary fat is not just dietary fat, it depends on the classification of the saturation as well. There's good evidence that, for example, within the saturated fat classification of fatty acids, the different chain lengths have different effects on, for example, plasma lipoprotein levels. Some of the chain length seems to have a differing ability to cause changes in those lipoprotein levels. So saying that saturated fat causes an increase, for example, in low density lipoprotein cholesterol is not only misleading because you're not qualifying which saturated fat you're talking about, it's probably not also true. So many of these statements are that are made about dietary fat are very misleading, because dietary fat is not a single compound, and even within just the saturated fat group there are many different physiological responses that can occur. If we look at the of two of the unsaturated fats, the polyunsaturated fats that are, for example, essential fatty acids, we have linoleic acid, which is an omega-6 fatty acid, and we have alpha-linolenic acid, which is an omega-3 fatty acid. Those are both polyunsaturated fatty acids. The linoleic acid has 2 double bonds. The alpha-linolenic acid has 3 double bonds, and those two molecules are required for the formation of compounds called icosanoids, and those icosanoids are required for many different cell functions. They regulate cell function, including, particularly, which has been well researched, the inflammatory reaction. I've talked many times about how the ratio of omega-6 to omega-3 fats in the diet needs to be roughly 3 grams of linoleic acid for every 1 gram of alpha-linolenic acid. And then therefore you can see that if you start to consume what we call a low-fat diet, what does that actually mean in terms of the ratio between the linoleic acid and the alpha-linolenic acid? It becomes a meaningless term unless you qualify it in terms of the amount of essential fats that you have in your diet. So again, that's another illustration that an understanding of dietary fats is very important, and you always have to qualify the statements that you make. If we then go to the omega-3 fats and the essentiality of the omega-3 fats, you don't actually need alpha-linolenic acid in your diet if you have, for example, some of the fish oils in your diet. Some of the longer chain marine oils, such as icosapentaenoic acid, which has 20 carbons, and docosahexaenoic acid, which has 22 carbons, they have 5 and 6 double bonds respectively. They can actually substitute for alpha-linolenic acid in the diet. So again, this adds another layer of complexity, and therefore you have to say, what do you actually mean by dietary fat? Which fats are you referring to? The fish oils, for example, have very, very different effects, even to the alpha-linolenic acid that you may have in your diet, even though they're ultimately converted theoretically into the same compounds. They're needed in different amounts. they have other effects as well. The docosahexaenoic acid has effects that the icosapentaenoic acid doesn't have. And therefore, even if icosapentaenoic acid is only a single conversion away from docosahexaenoic acid, is next to it in the metabolic pathway, yet the docosahexaenoic acid has a very different role, it appears, from the icosapentaenoic acid, which is why fish oils may actually have different effects to algal oils, which only contain the docosahexaenoic acid. So even within this small area of fatty acids, there is huge variation. There is a huge amount of, there are differences between the compounds. So again, what do you mean by dietary fat? What are you talking about? Are we talking about saturated, unsaturated? Within the unsaturated, are we talking about monounsaturated or polyunsaturated? There's other layers of confusion as well, because, for example, olive oil is a rich source of oleic acid, which is an monounsaturated fatty acid. And many studies have looked at the effects of monounsaturated fatty acids using olive oil, and many of them have not controlled for the phytochemicals that are suspended within olive oil. So many of the effects of monounsaturated fatty acids may have been incorrectly attributed to the consumption, for example, of olive oil, when really it's the consumption of olives that is beneficial because they contain these phytochemicals. So really, there's a lot of confounding variables and there's a lot of confusion about fat, and therefore you always need to qualify what you're talking about. Another group of dietary lipids that's very important is cholesterol. Everybody will have heard of cholesterol. Mainstream medical opinion is that increasing dietary cholesterol levels causes or is a cause of heart disease, yet the nutritional literature is quite clear that that is not the case. Your dietary ingestion of cholesterol, levels of cholesterol, pale into insignificance in terms of the amount you can actually synthesize in your liver. Cholesterol is synthesized endogenously. It's synthesized from it can be synthesized from amino acids, from sugars, for example. They form acetate, small 2-carbon groups. They're rearranged into squalene, and squalene is then converted into cholesterol. And your body can manufacture large amounts of cholesterol every day, and it does. The amount that you manufacture in your liver is much more than you get in your diet. And if you eat more in your diet, all that happens is that your body synthesizes less cholesterol. So cholesterol is another of these molecules that is used by cell membranes to regulate their fluidity. That's possibly one of the main functions of cholesterol, and it's so important for cell membranes to be able to regulate this membrane fluidity. They actually have their ability to make cholesterol themselves, and the more cholesterol molecules you fit into the cell membrane, the more rigid it becomes. The more cholesterol you remove from the membrane, the more fluid it becomes. So saturated fat, cholesterol, and the polyunsaturated fatty acids can have this important membrane fluidity regulating role, and they're all required. The cells need all three of those fatty acids, and they need them in the correct ratios. Cholesterol is obviously transported around the body, and this is where it gets its bad name, because it's also transported in lipoproteins, and there is an association between an increase in levels of certain lipoproteins and a decrease in other lipoproteins and your risk of cardiovascular disease. But cause and effect is not the same as an association, and that should always be taken into account. So cholesterol is a very important lipid. It's obviously very rich in certain foods. It's not present in plant foods, so a plant-based diet will have less, for example, cholesterol in it than an animal-based diet. But plants contain their own forms of cholesterol. It contains their own steroid hormones, which is what cholesterol is, and they're called sterols in plants. They're generally called phytosterols or sterols. They're actually alcohol steroids. They have a hydroxyl group on the 3 position of the they have an OH group, a hydroxyl group, which is also called an alcohol group, on the 3 position of the alpha ring, and this is why they're also called alcohol steroids. And they're very similar to cholesterol in their structure. They have very different effects to cholesterol, though. In fact, they may be able to block the absorption of cholesterol in the gastrointestinal tract, and they may also be able to inhibit the conversion of cholesterol to some of the other substances that cholesterol is converted to, like the steroid hormones, like testosterone, estrogen, and progesterone. So sterols and steroids they're the same group. They're all called. They're all from steroids. Cholesterol is a steroid. Some of the sterols in plants, such as camposterol, cytosterol, these are also steroids, but they have a slightly different structure, and again they have completely different effects. Very wide range. Even just looking at the steroids that are in the diet, the steroids have, depending on their source, very different effects. And then we come to vitamin D, which is also a steroid hormone. It's synthesized in our, we can synthesize it endogenously actually from cholesterol, but we can also get it from the diet. It's a steroid hormone, and obviously it has completely different effects to cholesterol. It's still a dietary lipid. It's still a steroid hormone. It's related to the sterols. It has none of the same effects really. It binds to the vitamin D receptor in the nuclear DNA, and there it has effects to regulate cell function, including immune functions, inflammatory reactions, and it's also obviously known classically for regulating calcium as well. So though even within the steroids, which are a group of lipids, there is a very, very wide-ranging effects. So when somebody says dietary fat, do you mean steroids? And which steroid do you mean? And even within the sterols of the plants, the sterols, the main sterols that have been investigated, camposterol, cytosterol, there are differences in their efficiency in terms of their ability to block the absorption of cholesterol. Some of them have some effects, some of them have other effects. So these nuances are very interesting, and they really just highlight the absurdity of calling, of making these statements about dietary fat. Then we come to phospholipids. Phospholipids are very similar to triglycerides, but again, although their structure is similar, they have completely different effects. Whereas a triglyceride is a glycerol backbone with 3 fatty acids bonded to that glycerol backbone. A phospholipid is 2 fatty acids bonded to that glycerol backbone, but then on the third position there's actually a phosphate group, and that changes the polarity of the molecule. It means that it's now amphiphilic, which means that it can be attracted to both water and fat, and this is why they're used in cell membranes. Phospholipids are also required for the absorption of fat because of their properties. They help with the emulsification of fat in water-soluble environments. And they're used as to form cell membranes. They are cell membranes. This is how cell membranes form. There is a particular dietary phospholipid called phosphatidylcholine, which is also known as lecithin, which is very important. That is 2 fatty acids with a phosphate group joined to a glycerol backbone, but the phosphate group also has a choline group attached to it. Now there's evidence that lecithin is a very important molecule. It's not essential, but there is some evidence that low dietary levels low production levels endogenously, which can occur for particular reasons, do require a certain amount of lecithin in the diet. So we could say it's possibly conditionally essential. Particularly if you have a build-up of fats in the liver, because one of the things that lecithin does is it actually increases the oxidation rate of fats in the liver. So treating, for example, non-alcoholic fatty liver disease or alcoholic fatty liver disease with lecithin may be effective. There is evidence that it may actually increase the oxidation of fats in the liver, and that's very different to any of the effects that any of the triglycerides would have. So although it's structurally very similar, it's just a fatty acid, or instead of having a fatty acid, it's got a phosphate group there with a choline attached to it. Structurally similar, has completely different effects. So if you are talking about low-fat diets, it's very, very easy to get confused with all of this terminology. And then lastly, we come to the vitamins that are also classified as dietary lipids. So we would have, for example, vitamin D we've already mentioned vitamin D, which is a dietary lipid. We've got vitamin A, which is a dietary lipid, a group of dietary lipids. You could also include the carotenoids in with that as well, because they're just really structurally 2 vitamin A molecules joined together. And then we have vitamin K and we have vitamin E, which are the fat-soluble vitamin E's. That's the fat-soluble vitamins. They're all dietary lipids. They all have very different structures. They all have very different effects. You know, while vitamin E, for example, is an antioxidant, vitamin D is responsible for immune regulation and calcium regulation. Very different effects. Vitamin A is required for efficient sight. It has other effects on cell regulation as well. Like vitamin D, it can bind to vitamin A receptors in the cell and cause changes in cell regulation. And beta carotenoid, beta carotene and the carotenoids are very effective antioxidants, but they're antioxidants in different ways to vitamin E. They complement vitamin E. They don't have the same scavenging ability. They're very good at scavenging, for example, singlet oxygen, whereas vitamin E is more of an antioxidant that's designed to protect lipids from lipid peroxidation. So even within the fat soluble vitamins, there is a wide range of effects. And I hope this video has done what I wanted it to do, which is to illustrate that when somebody is writing about, talking about fat, low-fat diets, high-fat diets, what do they actually mean? Fat is a very, very complex group. It really should be called lipids, and I've just scratched the surface with this video. There are many other lipids that I haven't mentioned, and there's a lot of information that I haven't talked about. I haven't gone into any of the detail really. It was just an illustrative video to say, always question when somebody talks about dietary fat. If you read an article about dietary fat and they're not qualifying what they're talking about, be very suspicious of their motives, because by grouping a very complex and heterogeneous group such as fat and simplifying it into a single statement or a single word, dietary fat, you can actually mislead people. And I think this is one of the reasons why often the details are missed out of particular articles or on particular videos. So obviously in certain circumstances people won't know the differences, but I think in many cases people do know the differences and they leave out the details in order to be able to mislead people. And therefore, educating yourself about the different forms, the different classifications of fat, and which fats are essential, which fats aren't essential, and the effects they have in the body is a very good way of improving your health and improving your nutrition knowledge, which means that you become your own nutritionist, which is what I keep saying. You need to be your own nutritionist. You need to look after your own body, and to do that you need the knowledge and the background information to be able to take information and analyze whether that information is useful or whether it is designed to mislead you. So don't take my word for this. Please do some research on dietary fats. Have a look at the dietary lipids and all of the different classifications of fat, dietary fats. Look at the chain length, look at the saturation level. Is it a straight chain? Is it a ring structure like a steroid? And what effects do they have in the body? And that's the sort of thing you need to arm yourself with when you're studying nutrition. So I hope that was helpful. It's really just a very brief overview. There is some further information on my blog if you want to go to my blog and have a look. Look there. The blog address is in the description below this video. So with this knowledge you will be able to hopefully eat better, you'll be able to eat well, you'll be able to protect yourself, and you'll be able to stay healthy. And with that I will hopefully see you again soon for another video, and in the meantime please take care.